Okay, this is part 2 of a video that I started earlier that was showing problem number 14 on page 362. And we left off right at this point, except that while you were changing videos, I was doing this. Okay, I was setting up the molar mass for sulfuric acid. And we're going to need that a little bit later on in this calculation. But right now we have to tackle this guy. And just as a review, if we go back to our little chart on stoichiometry, we had gotten from a couple of fractions, we had the given over 1, that was this guy right here. And then we had changing from grams to moles of SO2, that was this guy right here. Now we're going to tackle this one, which is where we actually do our stoichiometry, going from moles of the given to moles of the unknown or find. We always have to do that in any stoichiometry problem. And for that only, we use our coefficients in the balanced equation. Now we're trying to go from SO2 to sulfuric acid. So our mole ratio is going to involve this guy and this guy. So let's just put boxes around them because that's where our mole ratios are going to come from. And on the bottom, we have to have 1 mole of SO2 because that's what we have up here, SO2. And it may not be 1, but just moles of SO2 is what we need on the bottom. On the top, we're going to need moles of H2SO4. So we go to our 2SO2, the sulfur dioxide, and the sulfuric acid, and we look at the coefficients, and that's what goes down here. So for the SO2, there's going to be a 2 in front, and for the sulfuric acid, there will also be a 2 in front. And that's where these numbers are coming from. Now, it's just like the old stoichiometry problems. It's sitting us right here, and we're trying to get to this guy, because grams is what we were asked to find in our problem. So now we just go back and we look at the molar mass for sulfuric acid, and what we look up here to see what we're going to put down here. This is going to be moles of H2SO4. And up here we're going to have grams, because we're going to grams, H2SO4. And now these numbers right here are what we're going to use. With the moles, we have the number 1. And with the sulfuric acid, the grams, we have 98.1. And now we're ready to do the calculator magic, and the actual answer to this problem I'm going to put down here. And this whole thing is going to be equal to 3.83 after we round. Okay, I did something a little bit wrong. This was actually given as 2.50, and we had 2.50 here, which means that we have 3 sig figs here, 3 sig figs here, 3 sig figs here. So when we're doing our final sig figs, we got to have 3. Notice that these 2's here do not change the number of sig figs because they are infinitely accurate. This 2 is 2 moles. It's an exact number, and so it's infinitely accurate, as is this one. So we get down here, and the smallest number of sig figs that we have in any of our numbers is 3, and that's why we have to round this number from the calculator and get it to this number. And so the unit of measure is grams of H2SO4, and we are done. So in review of how to solve this type of problem, if you'll have this chart with you at all times, and this should be in your section called Standard 3, because that's where this type of stuff is done, is in Standard 3. And reviewing, we started with a given, which was in grams, and we were asked to find a different substance in the balanced equation that was also grams in the end. So, how many fractions did we have? Putting the given over 1 at this step is our first fraction. Then we have to go to moles. That's our second fraction. When we change from moles of SO2 to moles of sulfuric acid, we were taking this trip using the balanced equation. And after we got down here, we had to go to here, and that's our fourth fraction. I hope this is going to be helpful for you in solving all your stoichiometry problems, and thank you for watching.